Hello everyone. So we'll wait for probably 4 or 5 more minutes and then I'll start the session. Okay, I'll start now. So, can someone confirm if my screen is visible and I'm audible?
Yes, sir, you're audible.
Okay, and this screen is also visible, right?
Yes, sir.
Okay, great. Also, during the whole presentation, wherever you want or wherever you have any query, just unmute yourself and feel free to ask any question. Okay. So, my name is Adarsh Kumar Verma, and I am a TA for this course, Foundation of R Software, and I am taking weekly live sessions. So, again, I will briefly go through all the things that have been covered during the entire week, and then we'll try to solve some questions and any other queries that you may have from the entire course, entire week's lectures. Okay. So these things I covered in the last lecture, live session as well, that how to install RStudio, but I will just go through it again. So in the previous lectures, we saw that how you can install R and to interpret different parts of R, how it works. So we looked into those parts earlier. Now from this lecture onwards, I will be mainly working with RStudio. But if you watch the lecture of the professor, Professor Salab, he will be probably mostly working with R console. Okay, so we'll be doing both. We'll be doing the same thing, but just a slightly different approach. I mean, commands will be same, everything will be same, but it is more user friendly. So I'll be using RStudio, but all commands will work here as well, and it is more user friendly, and it will help if you try to implement the same thing here. Okay. So how you can download RStudio is that you can simply search in Google, download RStudio, and you may end up in with such a page. And this page may change depending on when you are searching, because these people keep updating their websites. And for example, I can show you live demonstration once more. For example, if you simply say RStudio, so this is the actual website. Pause it, and if you go here. You will get an option to download RStudio. So now, as you can see, this is actually this interface is slightly different than those screenshots. So these things keep changing, but you will get all such options. So instead of going with the RStudio server, you can go with download RStudio. So it will download a local version of RStudio on your system. Okay, which with which you can work offline as well. So once you click here, it will redirect you to another page. So here, if you go down, so again, this second page, uh, it does not look like this. Instead, when you scroll down, you will get an option to download uh, different versions of this RStudio depending and different operating systems. Okay, for example, if you're using Windows, you can download, so this exe file is the application file. So you can simply download it and install it. If you're a Mac user, you can download this RStudio ending with .dmg. Okay, and if you are using Linux or Ubuntu, then you can go with this Debian version or DEV. So so I hope all of you have already installed RStudio. Can someone confirm me if you guys have already tried installing and it worked or not? Uh, you can put in comments as well if anyone is facing any problem with installing RStudio. Maybe some answers from some of you, particularly if it did not work out.
Instant, sir. Good evening, sir. Instant.
Okay. Anyone facing problem with installing RStudio? Okay, so I hope everyone installed. Yeah. Anyone faced problem with this? Okay. So since everyone have installed it, so see, at one point you may experience some problem when you are working with RStudio or R, because some of the packages require some external, compilations. So one thing is that I mentioned, if you are a Windows user, you should install that R tools. Initially, if you have not installed R tools, it will work unless you require some specific package which requires that R tools. Okay. So as I mentioned earlier, if you are installing R, you don't in Windows, you don't need to just install R. You need R plus R tools, and if you are working with R Studio, you need to install this R Studio as well. Okay. In case in future if you are facing any problem, let me know. We'll try to look into it. Okay. Okay, so once you install RStudio, this is the basic thing you will see when you will open it for the first time. Okay, initially you will see three windows. Ultimately, it will change to four windows. So in here you will see mainly initially you will see three windows. So one is R console, which is the basic R that you see when you download R, not RStudio. So it is the exact same window here. Everything will run as it runs in basic R console. Okay. Next thing is the environment window. So here everything you will work with, or for example, every variable you save, for example, x equals to 2. So all those things will start appearing here as you save more and more variables or tables or functions and many more things. Okay, all those things will appear in the environment. History simply shows all your previous commands. And this another tab which you see here is files, plots, packages, help, and sometimes few more windows like plots and or viewer and so on. So I will also show you how it looks. Okay. So initially you'll be seeing something like this. So when you'll open for the first time, here there'll be some basic text, which is the basic information about your R versions and R version and so on. So this is what you will initially see. So this is basic R console where you'll be typing or wherever where everything will run. For example, here as you run in R console, you can say equals to 1. So now what you see is that you can type here. When as soon as you hit enter, that variable will go into your environment and you can reuse that variable again and again. For example, b equals to a plus 5. So that's what it means, that whatever you will run, those outputs will go. I mean, if you are saving that particular output in some variable, that will go into environment, which you will be able to later reuse it.
Your
Sorry,
screen is not
screen
visible.
screen is not visible. Is the screen not visible?
So it is visible from my side.
Okay.
It is visible.
So for whom it,
Your screen is not visible.
I think there is some problem in your internet connectivity. Maybe you can try reconnecting. Since it is visible to everyone else. So I hope that is a problem with your internet connection or something. So I will continue. You can just try restarting your reconnecting your sorry, this Google Meet. Okay. Okay. So here, whatever you'll be typing or whatever values you'll be saving in any variable, those things will appear in this environment, and anything which you'll be plotting will be coming here. And files, so when you click on files, it will show you current working directory. We'll come to it how you can see those things with codes. We'll look into that. As of now, I will just show what all these different things are. I also talked in the last session, but I will just go through it again. And so here files, so whatever you are seeing here, so this is your current working directory, and these are all the things which are already there in your current working directory. Okay. Plots is a place where different plots will pop up. For example, if I say a equals to c, let's type different numbers. Okay, now if I simply plot it, we'll come to it how to plot things, how to do calculations later on, so don't worry about that. I am right now I'm just demonstrating how things work and where different things appear and so on. Okay, so now here if you see all the variable, for example, I saved few values in a, for example 2, 3, 4 and 6. You see those values appear under a variable in the environment. I saved another set of values, let's say 23, 34, 12 and 23 in another variable called b. Again it appeared in the uh, this thing environment. Then what I did, I plotted a into a, values of a versus b. Okay, which you can see on x-axis it plotted a, and on b-axis it plotted uh, in y-axis it plotted b values, and these are the respective plots. Okay, then this whole plot you can change it, you can look it more, make it look more appealing and so on. There are many things you can do with R. This is very basic thing that I am showing as of now. Okay, now here if you see one thing, right now I simply plotted a comma b. You got a plot under plot section. Okay, but nothing changed in the environment variable. Why? So as I mentioned earlier, if you are putting anything under any variable, okay, for example here a is our variable, b is our variable. Okay, if we try to save something in a particular any variable, then it will appear in the environment. Since here I did not saved anything under any variable, I simply plotted my existing data, that's why it appeared here, but not, it did not appear in the environment. Now can we make it appear in the environment, or can we save this particular plot under some variable? Okay, yes, we can do that as well. For example, I can say uh, let's say plot 1. Okay, so instead of using equals to, I will be now onwards using this symbol for equals to. Okay, so now if I do this, okay, and if I hit enter, you will see another variable will be appearing here. Currently, it is not saving it. It is not able to save it in this variable. That's why it put the value null. But if later will be moved to another type of plotting called gg, so will be there is another function or another complete package called ggplot. Okay. Uh, it is a very big or very comprehensive library where you can almost all aspects of a plot, and you can make it look whatever way you want. You can tweak all the parameters of any plot, like y-axis, x-axis, labels, height of the plot, width of the plot, uh, difference between x ticks, y ticks, and many more things. Okay, all those things can be changed, and in that case you can save those particular plots in different variables, and you can later regenerate them without typing more and more code. Okay, for example, later if you simply type plot 1 here, it will generate that plot here. You don't need to write entire code. So that's what I'm telling. This plot itself, you can save it in a particular variable, and all those things you'll be able to see inside the environment. Okay, now till now we this is the three window thing which you will see when you initially open RStudio for the very first time, after installing. Next time onwards, you will probably using something like this. So we'll be dealing with this R script. There are many more options, so we'll not go into those things as of now. Uh, so one thing that you may be interested in is that R notebook or R markdown. So these are more like if you have used Jupyter, okay, Jupyter notebook and so on, or other type of notebooks, you may see that it gives you an option to enter some code in some lines, and in the following lines it allows you to write normal text. In following lines it can generate output and so on. So that those are those notebooks. We'll not go into those things because it may complicate this R thing for you. So as of now, you'll be simply working with this R scripts. Okay, and you may never need to go into those things. So if needed, we'll talk about that as well. Okay. As of now, whenever you're typing, I will suggest that whenever you're doing any type of calculation, make this as a habit to write things in a R script. Okay, you can simply click on this plus symbol and open R script, or you can go into file and click on new file and R script, whatever way is feasible for you. Okay. Okay. So once you are doing this, so after that you can simply start writing those things. For example, you can type any set of values. Okay. And last time I mentioned why I'm using C. So C you particularly use when you want to put more than one values under some variable. Okay, so it's called an array. Sorry, vector. Okay, we'll talk about those things also in upcoming slides. Don't worry about those. So let's okay. So let's say these are two variables, and I want to plot a comma b. So I can put my cursor anywhere and hit run, or I can simply put my cursor anywhere on that line, whichever I want to run, or I can highlight the entire line. All things will work, but and I can hit Control Enter, but it will not run if I highlight some part of it. Okay, this will give you an error. This will not work. So either you put your cursor simply on any line, hit Control Enter, or you select entire line that you want to run, or if you want to run more than one line at the same time, you can select more than one line. In that case, you need to highlight both lines together, or three, four, or whatever number of lines you want. You can simply select all and run. That will simply run all these three lines in one go. Okay. So these are some basic features, okay, which you should be aware of. Okay. So for example, and if you hit Control Enter, this cursor automatically goes to next line. Okay. So for example, if I run this, you see, I simply hit Control Enter, my cursor went to next line, and it run A. So let me clear these things first. Let me clear this as well. Okay, let's start again. So even if I put my cursor at the first line and I hit Control Enter, so since there is nothing, so it will skip the empty line and it will run the first line wherever some code is there. Okay, and you see this first line has been run in our console, and that variable appear in my environment. Similarly, I can simply keep hitting Control Enter, and it will run that line, and it will go to the next line automatically. So you don't need to manually, put click on that line. That will work on its own unless you want to skip some lines. In that case, you need to go through your cursor. Okay. So as of now, I hope you are able to understand how things are working and how and where the different things are appearing. Okay. Now this package section, so it simply shows what all package has been installed in your system. Okay, depending on when you whatever all external libraries plus internal libraries. For example, when you install basic R, okay, it comes with different packages. Okay, some inbuilt packages or base packages, so all those will be listed here. Along with that, when you'll be installing some external packages, okay, for example, when you type install.packages, which we talked about in the last session, that when you type install.packages and type different library names or package names, those things, everything will appear here. What is ticked here is the current packages which are already loaded in your environment. For example, if I want to use, let's say, this boot, okay, I will not be able to use it unless I load. Okay, and if I click tick here, you can see it will automatically run that code which can load this particular package. For example, library in bracket boot. You can do this if you want to load or unload, but it is not very common practice because people prefer writing instead of using GUI options. Because see, for example, today you are trying to run this command. Okay, you know that you need this boot package. You can come here, you can click here, well and good. Okay, let's say after 2 months again you want to run the same script. Okay, you already have a script, but instead, let's say you forgot that you need this boot package for the same. Okay, you need to load this boot package, so then in that case it will not work. Instead, what you can do, so instead of going through this GUI option, ticking and unticking things, you can simply put these commands at the beginning of your script. Okay, so every time you will run that script which requires these functions, it will simply automatically run as soon as you Control A and hit enter. Okay, Control Enter, so it will automatically load libraries, run the commands, everything will be done in one go. Okay, so that's a better practice to write code instead of looking for alternative GUI options. Okay, and since you are starting learning with R, so it's a good time to start practicing those things, because once you dive into more deeper things, it will be difficult to get into these habits. So since it is starting, it is uh, good for you if you use this approach instead. Okay, help tab simply shows you uh, any documentation of any package. For example, I don't know how to use plot. Okay, and then what I can say, I can simply type question mark, or let me run everything here. So I can simply say question mark and type plot. Okay, so now you can see, so this plot function actually appears in two packages. Okay, that's what my help function is showing me. Okay, one, it is coming in graphics package, and another it is coming in base package. Okay, now we can run either, but as of now we are running base package. Okay, so we can simply click on it, and there are many things we can see. So here again, that uh, page will appear. So when we click into graphics, so there are many plot functions available. If you click on any, you will get many options. Okay, so and similarly, if you want to look for any other function, how to use it, you will get different options, or uh, like what that function is built for, how you can use that particular function, what are different values or different inputs mean. For example, it is asking for your formula, what that formula means, that information you can get uh, within this help function. And uh, if you browse down, you will get the examples and so on. Okay, that can help you get started with a particular function. Okay, so this is help menu. Viewer, it uh, plots and other type of figures. We will not talk about that. And presentation, those things also will skip as of now. Okay, so this is how basic functioning of RStudio. Okay, and now onwards working with this RStudio only. I will not be working with this R console as such. Okay, if you want, you can simply type here, that is basic R. Okay, okay. So any question till here of anyone? Anything you are not able to understand how our studio works, why it is different? Any query that you may have? No? Okay, we will proceed. Okay, so in when we are talking about our console, we saw that one thing we called as our console, and another, if we want to type that script, instead of directly typing into our console, we open another text editor. So this text editor is same as this window. Okay, first window, which is our script. So that is the same thing. Okay. Yeah.
Sir, good evening, sir. I have
Yes.
one.
Yeah.
Um, sir, what is that? Terminal means?
So, okay, I did not talk about this thing. So, terminal. So, in your Windows PC, so in your Windows, you have command window. You know about command window, based on which you can run.
Console.
No. So, console.
Near to console, there is a terminal background jobs.
Yeah. Yeah.
What
So,
is that?
console is normal R console. Okay, which you get when you open simply R. Okay. Terminal is actually my system's. So this terminal is so I can open any application or do anything on my Mac, not RStudio simply. Okay, so terminal is your operating system's default window, you can say, with which you can operate your entire system. Okay, so for example, in Mac we call it terminal. In Windows, we call it command window, and so on. Okay, so this is not specific to R or RStudio, it is specific to your operating system. Okay, so you don't need
Okay.
to run things here. So for example, here from here you can open different sorry, different folders and copy paste different files and so on, many more things. So that job terminal does or command window does. Okay, so that is not specific to R, that's why I skipped that as of now. And this background jobs, so this mainly, so you, when you are running some loop, okay, which is quite long, or any calculations which is very huge, for example, which can go to more than 1 or 2 seconds to hours. Okay, in that case, you will start seeing something appearing in background jobs. Okay, and here something, some symbol may appear, or usually it appears here only, where if you click, so it gives red octagon type symbol, where if you click, it will help you stop the ongoing process. So all the background jobs that will be running at that time will be appearing here. So these things are not uh, required, I mean not required, that's why I skipped
Oh,
that part, but that's what these two
okay.
windows are.
Okay. Thank you. Thanks.
So even I can show you. So as you can see under terminal, so this is the basic thing that appeared. For example, now if I open my Mac OS basic terminal, so you see it is showing exact same thing. Okay, this is my username followed by my operating system, and I can type all my basic things here which are relevant to my system rather than R. And if you see, this exact same thing is appearing under terminal. So this is the same thing. Okay. And but this is where your R will be working, this console. Okay, let's move to next. So I already talked about all these four windows. Now coming to some basic functions of R, or some very basics of R. Okay. So first thing is current working directory. So what is current working directory? Why we need it? Let's talk a little bit about it. Okay. First, okay, let's show you what is my working directory. So this is the function which you can use for fetching your working directory. I will tell what is actually working directory. Okay. So working directory is a place where if you're running something, okay, for example, I generated this plot, okay, and if I simply try to save my plot, okay, where those things will go, okay, that's the that's my working directory, where if I simply save anything from my R Studio or anything, that will go to that particular folder. Okay, and that folder is your working directory, and that's the exact same thing which you get here when you click on files. Okay, so this is my working directory. Okay, now when you will see over time that when we'll proceed further, when we'll try to save some things or some plots or some files, output excel sheets and so on. Okay, for example, let me plot. So I generated this plot. Okay, if I simply, so I can save it with code also, I can save it with GUI. For simplicity, let's show you with GUI. For example, I can simply click on export option. I can click on save as image. Now I can simply save. Okay, and it is giving me some default option, default name. I can simply click save. Okay, now people do that. I taught in IITs. During final examination, I saw people struggling with this part. Okay, because when we ask people to upload their R scripts or plots and so on, they, after saving, they are not able to find where those things actually are. Okay, so that's what I want to clarify at this point, that where these things are actually going. Okay, so this is your current working directory where these things will go. And simply if I try to save my this R script also, okay, because at the end if I ask you to send me all your codes that you have write for a particular assignment or anything, okay, so what you can do, you simply go to file, you can simply give save, and you'll probably end up saving it. Okay, and then while looking for that thing, you will probably go to your this thing, and you can probably search into downloads and so on. Okay, and you will not find it there because you did never saved it there. Okay, where you actually saved is this exact location, where you need to go into users and other schema, and it is different from your normal downloads desktop or document directory. Okay, so this thing you need to be very clear when you are trying to save anything. And because of this thing only, I always prefer to provide entire path rather than uh, simply putting the uh, file name or plot name and so on. So we'll talk about those things in upcoming lecture, don't worry about that. But as of now, this is just to show you that if you're trying to save anything from your R studio or R anything, okay, everything will go to your this current working directory, okay, which you can definitely change. Okay, for example, I can show you where exactly my that plot or that untitled.r file went. Okay, for example, I can open my basic things. Now you can see I need to go into users. I can go into users, then my folder, and here if you see I can find my R plot. Okay, and I can also find my R script. Okay, so that's what you should be aware of, where exactly your things are going. Okay, that you should understand. Okay, how your operating system works. This is not specific to R, this is specific to any programming language. Okay, and so if you want to get your working directory with code, you can type get wd and empty brackets, and you can hit control enter. It will print the current working directory. Okay, now if you want to change your working directory, instead of get wd, you can type set wd. Okay, for example, set wd. Okay, now here you need to provide the entire path where exactly you want to change that. For example, I can in downloads I can make a folder, for example, demo, and I can, so there's some problem, I mean, so I can copy the entire path name and I can put it here. And since, as I mentioned in the last lecture, whenever you are dealing with any string, okay, that is if something is not numerical, you need to put that thing under inverted commas, whether single or double, it's up to you. So since this is a string, I need to put it under inverted commas. Okay, so now if I click set wd, I mean type set wd in bracket, provide the path, and I hit control enter, it will change my working directory. Now if I save something, it will go into this working directory. Okay, so I hope till here things are clear. Okay. Now one thing I would like to clear, which was actually wrong in the lectures that you have watched. Okay, if you have watched those lectures properly by Professor Salab, you might have remembered that he mentioned that if you want to view the contents of current working directory, you can type ls and uh, brackets open and close. Okay, but there is slight mismatch. What he exactly mentioned there to say is that if you want to see the content of your environment, in that case you need to use ls. But if you want to see the content of your current working directory, you need to use dir and brackets or list.files and that thing. Okay, for example, I will show you. So if I say dir, and so this is the exact data that I pasted in my this folder. Okay, since I changed my current working directory, so you can see, so here you see this is my working directory, our demo folder. Okay, and this is the file inside it. So everything inside that working directory or this folder is this one only file. Okay, so that's what you get once you type dir this thing, or you can type list.files. Okay, It is not necessary. So I can put a comment. I will share this R script in case you require it later. For example, fetching contents from current working directory. And see, when we talk about fetching content from working directory, we are fetching everything which is within this folder, okay, or which is within your current working directory, okay. Now if we want, and what has been mentioned in that lecture is that how to fetch content within your environment. So that ls, so this part what he told is actually fetching content from your current environment, and this is your environment. As we were talking earlier, that whatever information you will be saving in any variable, for example a, b, and so on, okay, so these variables, this is what you can fetch from ls in bracket. Actually what he mentioned was just a, uh, I mean, terminology was wrong. Instead of environment he mentioned current working directory. That's what I just wanted to correct for clarity, okay. So if I run this part, you see it is listing out A and B because these are the two variables I have in my current environment. Okay. So that's what it means. Okay. So I can put comment here as well. Okay. So you should, there should be clarity in where from where you are fetching the information, whether you are fetching from environment or working directory or from anywhere else. Okay. Next, so exact same thing I mentioned here. Next, how you can change the working directory, that also we mentioned. So another thing is that how you can interrupt any ongoing process or quit complete RStudio. So in that case, you can, if you want to quit RStudio, you can type q and you'll be able to quit the entire RStudio or R console, anything. Okay, whatever you are working on, quit R simply. Okay, and if so, as I mentioned earlier, that when you are running a loop which can run from seconds to minutes to hours, okay, let's say at one point you want to stop that process, you may no longer be interested in doing that work, okay, in that case you can press escape button, or as I mentioned earlier, you will get another option here. It will only appear when you are running that job, that long job. So in that case you can click on that icon, it will terminate the existing process, or you can type, or you can press the escape button or esc button on your system, so that will stop the ongoing process, okay. Next, if you want to clear everything from console, so that will only clear information from console if you hit control enter, okay, control l, or if you can click on this icon, it will do the same job. I can hit control and sorry, controller, 1 second, sorry, control L. So it will do the same job, whether you can hit control L or you can click on this broom icon and it will do the same job, okay. This this you don't usually require, but let's say you want to run some, you are running something, you want to see some output and there's already too much of information in that console. So in that case you can type control L and it will clear everything, then you can run your particular command and you can see the output. So that's where it is helpful when there's too much of output and you are looking into some output which you most recently done. In such cases you can clear it and uh, visualize your current results. Next, how you can clear the variables. So for that you can use a function called or simply rm. So for example, currently I have two variables a and b. So if I want to remove my one variable, I can type a. If I want to remove two variables, I can type both a and b together. Okay. Now here I mentioned earlier that when you are putting more than one variable or one entity inside anything, in that case you want to use C. You need to use C. But that is applicable when you are trying to save some information into some another variable. Okay. In that case, you need to use C. Here we are not doing any such job. Okay. Here we are just removing different existing variables. Okay. We are not changing anything inside these variables and so on. We are simply removing this. So here you don't need to use that C which we used for combined. Okay. So if I simply run this, it will clear my both variables. And here I can also put these variables into inverted commas or double inverted commas. Everything will work. Okay, so now if I hit control enter, so I can put these variable names without inverted commas, single inverted commas or double inverted commas. Everything works. Okay, so that's how you can use this rm function to remove or clear any of the existing variables. Next, so I already talked. So in the last lecture, I talked about what these indexes mean. For example, let's say, so whenever you will run any command which has a vector of so many numbers, you will see it will end up showing uh, different values in different rows. And in the very first column, you will see some numbers appearing in square brackets. Okay, so what these square brackets actually show is the index of the first value which is in that row. For example, in the entire list of 250 to 900 numbers, 250 is showing the first number, 270 is 21st number of that entire array or entire vector, 290 is 41st number of that entire array, and so on. Okay, so it is showing that where that particular number stand in the entire set of numbers. Okay, so this is the index which depict the first value. Okay, index of the first value. Okay, for example, this 890 is 641st number. Okay, and so on. So so don't confuse these square brackets. Those are just the index and not actually a result of your statistical analysis and so on. Okay, so keep that in mind. Next, whenever you are restarting your R studio or R anything, as soon as you restart all the packages, for example, if I need to use this boot package in my current session, I can load and I can work on it. But as soon as I restart my R Studio or R, I need to install or I need to load this package again, because as soon as you restart, whole environment will clear, whole session will clear, everything clears out. Okay, so your packages which you imported, those also will get detached. They will not be deleted, but they will be detached from your R session. Okay, and as soon as you reopen your R or R Studio, you need to load those libraries again to use them. Okay. So that is particularly applicable when these are external packages, because base packages load on its own as soon as you open these softwares, but external packages you need to reload. That's it. Another thing, when you will be starting with any statistical analysis, you will start seeing these scientific notations. For example, e minus or plus some number. Okay, so what it really means, for example, when you will do any correlation test or t-test, uh, in all these things you will see the p values, right? Because that's what you guys look, right? When you try to see difference between any two variables, or do ANOVA and so on, any type of analysis, we will end up seeing a p-value which is very, very less than 0.001 and so on. Okay. So as soon as you move beyond few decimal points, it converts those numbers into scientific notations. So what that exactly means, because for example, let's say your as any statistical output you got your p-value as 0.00005. Okay, now I can run it, but when you will see the output, you will not see this entire output most probably. So if I say p, so now what it is showing is that instead of showing me 0.00 these many zeros 5, instead it is showing me 5 e hyphen 10. So what it says is that I need to go 10 more decimals behind 5. Okay, and if you do that, this is your exact value. Okay, so this is simply 5 into 10 to the power minus 10. Okay, so if I increase these numbers, you see now it changes to 5e minus 14. So what it means is that 5 into 10 to the power minus 14. Okay, so that's what it means. So these are the scientific notations. So here what it means is that when this is minus, so e hyphen 10, you will see that you need to add dot or decimal before that particular value. For example, you need to go 14 times before 5 and then put 0 decimal, and if it is plus, so instead you can have some number like this. Okay, so if it's like 5 crore and so on, okay, where there are multiple values or multiple zeros after 5, in that case you will see 5 e plus 11, that is 5 after 5 there are 11 zeros. Okay, so that's what plus and minus means. So it simply shows that where your value stands. Okay, and these numbers shows whether it is you need to append decimals or zeros. Okay, so that's the scientific notation of how R shows you the output uh, when these values are very long. Okay, next few more things. So as I mentioned earlier, as soon as you are adding any strings or try to put any strings, so okay, I didn't talk about it here. So for example, I can put I can make a variable called, let's say, fruits. Okay, here I can save multiple fruit names. For example, I can say save apple, I can save banana and so on. Okay, now currently one second. So currently one thing you need to notice is that if you are appending different variable different strings, or if you are trying to assign different strings to any variable, in that case, so as I mentioned earlier, you need to use C. That is the very first thing. Okay, without C you see that one X appears which was showing there is something wrong with this entire line. Okay, that's one thing. Another thing is that, as I mentioned earlier, you need to use single quotes or double quotes. Okay, so this thing actually I discourage, but it works in R. Okay, if I use single quotes, it will work, and within the same frame, if I put double inverted commas, that will also work. Okay, so for example, if I run it, you will not see any error, and if I simply try to see the output, you will see all my strings are in double inverted double quotes. Okay, so in R it works, but I suggest you not to do that, because see, in different programming languages logic remains the same. Okay, for example, when you switch from R to MATLAB to Python and so on, syntax changes but logic remains the same. So here using single quotes versus double quote does not matter, but as soon as you look into some other language, for example Python or MATLAB, you will see that actually matters. Okay, it will not let you append as it is allowing you to do in R. So it is always a good practice to stick with one type of quotes. Okay, either always use single quotes or always use double quotes. Don't mix single quotes and double quotes. Okay, it will work in R, that is not a problem, but avoid that. Okay, next. So these okay, so now if I let's say I can save a equals to 5. Okay, so here this is numeric value, but sometimes particularly when we'll be working with tables and so on, we'll come to it later on. So when you import data from your, let's say, Excel sheet, okay, when you collect data, you go for field work, you note down your data in different Excel sheets or JSON files and so on, right? So then you try to use that data, you import that data in your RStudio or any statistical software, you try to do the analysis. Okay, so here it is quite straightforward that you saved 5 into A, so that is numeric, well and good. Okay, no problem. But in that case, when you import that data, that particular column which you think that, let's, for example, these are age of students. Okay, you think that these are age which is, let's say, ranging from 18 to 25 or 30 and so on, that those are numerics, but R may not treat that particular column as a numeric. So sometimes that problem does occur. So that's where you need these functions, that is as dot numeric or is dot numeric, is dot character, because you can't add 25 or with 30 if both are strings. Okay, that will not work. Unless both are numbers, then only it will work. And how you can check, that's where these functions come, where you can type is dot numeric and you can type A. So we'll come to how you can fetch different columns or different data sets and so on. We'll look into those in upcoming lectures. So as of now, I was just telling you what is actually the use, because here when I'm checking, it seems quite useless. So I was just telling you rationale why actually you should know about this thing, why it matters. Okay, so now here you can see that since is 5 is a numerical value, and when I checked is my a numerical value, output is true. Okay, yes, that particular a value is true, is a numerical value. Similarly, you can check any column of any data frame. We'll see how later on. Okay. Similarly, you can check for example, you have different classes. Okay, class 1, 2, 3, 4, which you don't want to treat them as a numerical values. Those you want to treat them as strings. Okay, in that case, how you can check whether those are really strings? Because again, if it is numeric, it may behave weirdly in your data. Okay, it may not work as you expect. So in that case, how you can check? You can simply type is dot character. So character is used to check for any string or character type variables. So in that case, you can type again same variable, and it will give you an option of output of false. That is my a variable is a character or a string? No, output is false, that it is not a character. Okay, or not a string. So these things you need to worry about when you are dealing with tables or large data sets and so on. Okay. Next. Okay, so instead of typing is dot numeric or is dot character or typing, so let's say in your table, okay, or let me load a data set. So this is one inbuilt data set, empty cars. I will just try to load it under a data set name called data1. Okay, so now as soon as I click on it, you will see, so this is my data. Okay, empty cars, where one column is different car names, second column is miles per gallon, third column is CYL, displacement, HP, and many more variables. Okay, so these are so now if you want to view data, you can type view, so it will open a table. Okay, 1 second. Okay, it may not, sorry, this. Okay, okay, so it directly loaded empty cars, I think. Yes, so this empty cars is a inbuilt data set, okay, which is currently there in my environment. So as soon as you click here, it will open a new window which with this particular table, empty cars. Okay, so you can see here there are my table name, car names. These are different columns. Okay, now here I may think that this CYL, so okay, now let me show you the real use of those question mark and other things. Okay, so this is one inbuilt data set where you want to know that what are these different column names. So in that case, you can type question mark and type empty car. So since this is an inbuilt data set, there is some background information about this data set. Okay, so now if you go into this, okay, one more thing, all these windows you can resize as per your convenience. Okay, you don't need to, it doesn't need to be fixed. Okay, as per your convenience you can adjust them. Okay, so here if you go down, you can see what all these different variable names are. Okay, for example, first is miles per gallon, number of cylinders, and so on. Now you may think that CYL is a numerical value or a string value or character or factor, anything. Okay, so and when you try to do, let's say, ANOVA, whether you want to check whether miles per gallon differ based on how many cylinders are there, it may not work. Okay, unless that is a numerical or other type of values. So in that case, how you can check? So as soon as you go into these data sets, now these data sets has both rows and columns. Okay, and here if you want to fetch any particular column, okay, we may dive deep into how to work with tables and all in later lectures, but for as of now, just for your knowledge, I am telling, if you want to fetch any particular column, there are two ways you can do that. Either you can say column number, okay, you want to fetch second column, fourth column, sixth column, fifth column, and so on, or you can provide the name of that column, whether CYL, DISP. So all these are case sensitive. And how you can fetch a I will show both. So what you can do, let's say you want to fetch this second column, okay, CYL. So here, as in the data set, you can already see how to fetch. Okay, so as I mentioned, when you want to go for any index, so here what I am trying is that I want to fetch all the values from second column, okay, which are 6, 6, 4, 6, and so on. So when I'm talking about second column, what I'm really talking about is index. Okay, I'm not saying I want which value. Okay, I'm saying fetch all the values from second column. Okay, this is some form of index. And as I mentioned earlier, whenever we talk about index, we use square brackets. Okay, particularly in tables. So now if I say, so now one more thing, whenever you are in tables, there are two things: row comma column. Okay, and row always precede column in any code. Okay, so in R, if you are interested in all the rows, you simply leave the anything empty before comma. And which column you want? I want second column. So now I can put nothing before comma, that is all rows, comma 2, that is second column, and I can hit enter. So what it will do, it will fetch all the values from my second column, and now I can check whether that whole column is numeric or it's a character. Okay, now I can check. So yes, now this whole column is numeric. Okay, now we can change these numbers into characters. Okay, for example, and I will show why it matters. So by using is, instead of using is I can use as. Okay, as dot character, and you don't need to change. I am saying showing you what will happen when you will be dealing with real data sets. Okay, you don't need to change, it will be there when you load your data set. Okay, I am just showing that it will not differ visually. Okay, but it will change the data structure. Okay, so now if I copy the same thing again, so now if I again see this empty cars, I hope you are not seeing any difference from previous table. Okay, it's exactly same visually, there is no change, right? So what I did, okay, one second. Okay, so I simply put these values back into empty car second column. We'll see later how it works, so don't worry about that. Okay, so now if you see, nothing changed, all these values look exactly same it was earlier. Okay, all looks numeric, whether it is first column, second column, third column, and so on. There is no visual change. But now visually, since it is showing numbers, it should return this value as true again, right? But it is false. Now in that case, if you want to perform any numerical operation, it will throw an error, it will not proceed. Okay, it will give you an error. So that's what I am telling, that when you are dealing particularly with tables and other data frames, this is where it becomes really important. Okay, and now if you check as dot characters, sorry, okay, it is returning the strings, there may be something wrong. Okay, okay, instead of using this is dot numeric or is dot, sorry, I was supposed to use this. Okay, so now you can see all my values are character instead of numbers. I can change these values back to numbers using as dot numeric, and by putting the same, just like I put this as dot character, I can put back as dot numeric, and it will change all my values to numeric values. Okay, so till here I hope everything is clear. Now one thing I mentioned here, okay, leave that as of now. So this is the usage of is and as dot numeric or character. Okay, okay, let's show you this part. So structure, so as I mentioned, so when you deal with a particular variable, for example a equals to 5 you saved, and you want to check whether it is numeric or character, every time you need to type this long function. Okay, instead there is another simpler version, str, which means structure of a particular variable or data, anything you say. So here you can see that as soon as I type STRA, it shows that it is a number. Okay, so this is for your knowledge if you want to see what type of value these are. Now this become particularly helpful when you are dealing with data sets. Okay, for example, str, my data is empty cars. Okay, now if I run this value, you can see different informations. First, it is showing that my mpg column, it is numerical. My second column cylinder is character, although visually if you see here, there is no difference between first and second column in terms of whether it is number or character. But as soon as you type str or structure of empty cars, you see that first column is numbers, second column is character, third column is number, and so on. So that's where this structure function is quite helpful, particularly if you are trying to do some calculation and seeing some errors regarding the structure of the data. This is the thing you should check, okay, whether your data is in correct format or not. If not, convert it. Okay, next, how you can convert, we already talked. You can use as.numeric or as.character and so on. Another thing is that sometimes when you'll be running different things and in our particularly long scripts, you may see warnings or errors. Okay, warnings it produces when it is not trying to do some job, but still it proceeds with the analysis that you are trying to run. Okay, it may, for example, you are trying to do some calculation where there is a missing value. Okay, so in that case R may assign NA instead of missing value and proceed with the analysis. Okay, in that case it will give you an warning. Okay, and it will say that some values have been replaced with NA and this analysis has been done. Okay, so you can read the warning if required. In another scenarios, it can give you error. Error means that there is something critically wrong with your script, that R is not able to proceed. At one point it stopped. Okay, so that's the difference between warning and error. In warning it will print warning and it will proceed. In error it will stop the program. Okay, it will terminate it in between, and you need to go through your script, you need to check where the error occurred, you need to rectify or correct that error, and then you can proceed. Okay, that's the difference between warning and error in R. Next is comment. So when you are typing any code and you want to save some information that what that code is really doing or anything you want to type, you can put hashtag and you can type anything. So that will be used as a comment and it will not run. Actually it will just be printed. Okay, it will not be run. So that's how you can use comments. You can put this in a new line or just append at the end of the code on a particular line. Everything works. Okay, okay. Last thing is that everything in R is case sensitive since it is a programming language. Whenever you are using small a, use small a. If you are using capital A, use capital A. Whether it is string, variable names, folder names, anything, anywhere. Okay, everything is case sensitive. And this thing I already mentioned, that whenever you are trying to combine multiple values, whether it is numbers or strings, and you want to assign those multiple values to a particular variable, or you want to do any calculations with multiple values, you need to use C. Okay, for combining different values. Next, in basic mathematical operations, you might have learned there are different measures of central tendency, mean, median, mode, and so on. Okay, now in R, if you type mean, it will calculate that arithmetic mean. If you type median and in bracket you will put the data, it will calculate median. But if you type mode, it will not calculate mode because there is no inbuilt function for mode. Okay, that you can create your own function, or you can install external libraries and so on. Here mode means that what is the data type, so it is similar as is.numeric or is.character and so on. So it will type what type of data that is. Okay, whether it is character data or numeric data, that this mode will inform you. Okay, so don't confuse this mode with measures of central tendencies. Okay, that is different in R. And just like numeric and character, you can use is dot finite or is dot infinite to check whether your particular value is an infinite value or a finite value. Okay, few more things. So this R, it can be used as a normal calculator, like we were doing till now. For example, we can type anything like, so till now we were assigning values, right? So that was not like a calculator, but in calculator you simply, what you do, you simply type something, you enter different values, you divide, you multiply, and so on. Okay, and hit enter. So it will give you your final value. Okay, and it follows about Moore's rule, that it will first work with brackets, then any order related values, that is power related values. For example, let's say 34. So so in R or any programming language, power is denoted by this symbol. Okay, and here space doesn't matter. You can it's your wish whether you want to enter space or not. That will not affect the output. So now in that case, let me put some brackets as well. Okay, so in this case, what it will do, first it will solve this bracket, then it will solve this order, then so bracket order, then it will solve this division, then multiplication, then addition, and that is this part, then at the end it will do the subtraction. So this is what R do, unlike any other calculator. Okay, it always follows the Bodmas rule. Next, these curly brackets and square brackets, they are not considered in Bodmas rule, and it may throw up error if you use these brackets. So these are used for indexing purposes. So these curly brackets are used when you are dealing with lists and all. We will talk about it later on. Then these blank spaces has no role in mathematical operations, like in calculations, calculator, or other basic calculations. Now, one thing I would like to tell is that there are many different types of operators. Some of you which you might have already known, some you might have not. Okay, so here there are different arithmetic operators, relational operators, logical operators, assignment operators, and miscellaneous operators. Okay, now I will not go through all. I will just show you some basic ones. So plus, minus, multiplication, division, so those you already know. These are sort of division related operators. So for example, so if I say 9 divided by 4, okay, so in that case, so if so see, if I type 9 divided by 4, it will give me the complete value with decimals. Okay, if we are just interested in remainders, we can type double inverted commas. Okay, so double percentage symbols. So in that case, it will give me only remainder. Okay, if I am only interested in dividend, okay, not the remainder, that whole number dividend, so in that case I can put 9 in this, so in that case it is showing me 4 into 2 plus 1 is 9, so it is showing me a dividend of 2, not the remainder. So that's what these symbols do, which you may or may not use, because I never use till now. And this symbol, as I mentioned, is used for power. And relational operators, it shows less than, greater than, equals to, like whether a is equals to b or not. So that's what you check. So all these operators, they return the output in true or false. Okay, this shows less than or equals to, greater than or equals to, and it is not equals to. Okay, this exclamation mark is it reflects not. Okay, and whether a is not equals to b. So that's how you use these operators, these logical operators. And so these also return in true and false. We'll see the outputs if we need in future lectures. Okay, this and checks for whether a and b both are of something, I mean both relate to same category and so on. In that case you use and. If you check whether a or b, any of them relates to fruits, for example, in that case you use this symbol. If both are not, in that case you use this, and so on. Assignment operators, so till now we only talked about these these two, that is equals to and this part, right? These are the operators which can assign values to the other way. For example, till now you are saying a equals to 3, right? Even this we use for equals to, we say a equals to 3. We can use this where we can put 3 before it and put a after it. Then what it will do, it will put value before this particular function to the variable name after this function. So if you say 3 this function and then a, then it will assign a to 3. That's what this function do, although you will never need it. This operator colon, it is mainly used to write a sequence of numbers. Okay, for example 1 to 100, as you saw in the previous example, I used colon. So this is what it is used for when you try to write a different numbers in a sequence. This in percentage in sign, another percentage sign. So this is used for membership things. For example, you have a list of people. For example, you collected data from 100 participants. Okay, then one more person came to give the data and you wanted to check. Okay, for example, let's say someone is donating blood, okay, for money. Okay, one person, let's say already 100 people donated blood and get some money back. But after that, one more person came because he needed money and he wanted to donate blood. Now, how you can check whether he already donated or not? You have already a list of all the people. You don't want to manually go through all. In that case, you can use this function to check whether that particular name already appeared in the existing list. Okay, that's what this function does. So it checks for membership. Okay, whether a particular value is already a member of a particular set of values or not. Okay, and there are many more operators. We will see later if required. Okay, now final thing is that working with vectors. Okay, so till now we talked about these things, right? C in bracket, these different values. So these are vectors where you put different values together. Okay, so these are called vectors. Now how R works. Okay, now if I want to add some value, okay, I will not be using the variable name. So let's say only this I am using. Okay, I want to, let's say, add 4 to all these values. Okay, plus 4. Okay, so I want to use add 4 here also, second value also, 3 also, 4 also, and so on. So here, if there is only one value, it will work element wise. Element wise means same thing will be done with each of the value of this entire set. Okay, so if I run this, you will see the output. 4 is added here, 4 is added here, and all these values. Okay, now if I want to, let's say, add 4 and 5 to the first two values, then again 4 and 5 to the next two values, and so on. Okay, so here there are different options. So what I can do, I can put another list. Okay, what all I want to add. For example, I can put 2 3 2 3 2. So there are total how many values? So there are total 5 values. Okay, so here if I put 5 values and if I hit enter, so now it will not do element wise calculation. Instead what it will do, it will, so here earlier 4 was added to all the values. Okay, this 4 was added to all the values. Now same thing will not happen. Now only first value will be added to first value here, second with second, third with third, and fourth with fourth, and fifth with fifth. So that's how it will work. Now another way these things can work, if there are even number of values. Okay, it will not work for odd number of values. So let's say I want to add 2 3 2 3. I don't want to write very long list. So if I have only 4 values, then it will work. For example, 2 can come, it can, I mean 2 can be added, 3 can be added, again 2 can be added, and again 3 can be added. But it will not work if there is another value. Okay, if there is another value, then this whole sequence cannot be repeated. Okay, so if I try to run this, you will see that it is throwing me an error, that longer object length is not a multiplier of shorter object length. That is, length of this is not a multiple of length of this. Okay, that is 5 is not a multiple of 2 into 3 or 2 into 4. Okay, so that's what it means, that if you are trying to repeat the sequence, it should be a multiple of the larger number. Okay, so now if I run this, you see first 2 is added in 234, 3 is added in 54, again 2 is added in 234, again 3 is added in 5. Okay, so that's how these calculation between vectors work, and irrespective of whether you use plus, minus, multiplication, division, these vectors work the same way. Okay, so I hope this part is clear to everyone. Okay, so any query, anyone till here? Few things that I skipped, we will see later if required, because everything cannot be covered. Yeah, I'm open for questions. Anyone? You can simply unmute yourself if you have any query, then we can proceed with the questions. If anything is not clear or you want more clarification. Okay, I can show you that MISC operator. So particularly this you use very often, this you rarely use. Particularly this you use in scenarios like when you work with loops, or because there you do deal with condition that if that particular condition is fulfilled, then do these calculations, if another condition is fulfilled, do these calculations, and so on. That's where we use this. This I never used, so even I don't know as of now. I can check if you guys want. These two I can show. In first one I already showed that when you want a sequence of numbers, for example here I used this part. Okay. Now here, as I mentioned, I used, so let's say, okay, I can put other names. Okay, let's take example of this only. So let's say there are 100 apples, you can assume these as names also. Okay, let's say there are 100 names, and you want to check whether there is already, so here you can already see because there are only 3 strings. Okay, but if let's say there are 1000 fruits or so on,
you can't read the entire list. Okay, it is time consuming, resource consuming, and so on. Okay, so in that case I just want to check whether Apple is there in the entire list. Okay, so since I already saved these values in a particular variable, so I don't need to write these entire all values again. I can simply reuse this variable name, okay, or variable. So now if I see when I looked that whether apple is there in fruits, you can see it is showing true. Okay, now if I see whether oranges are there in the list, now you see that this particular value is not a member of the existing fruits. Okay, so that's where it helps. Okay, and its usage will become important when you deal with different conditions. Okay, which will make sense when we will run through some data sets. Okay, so that's how you can use these functions. Any other query? Anyone else? Any query? See, these live sessions are there so that any question you may have can be resolved. Okay, because whatever I taught probably in first 1 hour is already there in those 4 or 5 lectures of the entire week. You should make use of these live sessions. Okay, let's solve these questions. Okay, which command removes the variable a, b and c simultaneously, that is at the same time? A, B, or C, or D? Any other answers? Feel free to answer. It's right or wrong, doesn't matter, because here you are learning, no one is going to evaluate you. Okay, we are just checking whether you are getting the concepts or whatever we are telling or not. I need more answers. This is the question. Which command remove these variables simultaneously from your environment? No more answers? You can unmute also and speak. Okay, one option that is actually correct, I did not give that option. So A is correct, B is also correct. Okay, so when you are removing variables, you can use single quotes, double quotes, or no quotes. Everything works. Okay, in that case A and B both will work. And C is not correct because we are not supposed to use, we are not required to combine these A, B and C variables, and remove is not a function of R, so that is not required. So RM is used to remove a particular variable, but we can use either of these options which will actually remove these particular variables from our environment. Okay, so what is the output of the following command? X is equals to 4, y equals to x plus 7, and we want to compute whether the resulting value is a character or not, that is character in bracket y. A, B, C, or D, that is true, false, numeric, error. What will be the output? Yes, so it will return answer in terms of true or false, because you are asking it a logical question whether a particular condition is true or not, that is y is a character or not. So it will be a false answer, that is B. Good. Next, what will be the output of this? X is less than x is equals to 25. What will be the mode of x? Numeric, integer, character, or it will throw some error? Other answers? Few more. Respond in the chat. So what will be the answer of mode x? Numeric, integer, character, so here answer is C actually. That is character. Why character? Because we are assigning 25 to x, but we are putting it inside quotes. Okay, so it will not be saved as a numeric value into x, it will be saved as a character value inside x, and when you are checking for mode, that is the structure of the data, it will give output as a character. Okay, not a numeric. So this is particularly important when you are dealing or trying to do some computation between different variables and it throws error. In that case, you need to check whether the data structure or variable type, whether it matches or is compatible for computations or not. So currently it is not. If you want to add this x, so if you compute x plus 5, it will throw error. Okay, so that's where you can check mode, or you can use the structure or as.numeric. It's up to you. Okay, next, evaluate the expression. So this is the expression. You can tell at least 2-3 people should respond to it, because I will not compute it. Tell the answer of this expression. After that, I will probably run in R.
So option B.
B. Okay, let me check. So first of all, it will solve this part, that is order. After that, there is nothing inside this bracket except one value, so you don't need to worry about bracket. So after order, it will this part will be solved, then this part, after that this part, and then the remaining. So let's check. Yes, so answer will be 52. Next, what will be the output of this expression? Any other answers? So here correct answer is B only. So this one shows the index. So when you will type this in R, this will appear in the output, so ignore that part. Now, as I mentioned earlier, since there is only one value, so this is entire vector, and you are dividing that entire vector by 4. So since this is only one value, and as per board mass, this division will be solved first. So once you do that, so it will work element wise. Okay, so 4 divided by 4, which is 1. After that, 1 will be added, that is 2. So that is 2. After that 8 divided by 4, which is 2 plus 1 equals to 3. Similarly 12 divided by 4 plus 1 and 16 divided by 4 plus 1. So that will be 2, 3, 4 and 5. Okay, so if I would have provided, let's say, C4 comma 2, okay, in that case this 4 would have been divided by 4, 8 by 2, 12 by 4, 16 by 2. So that's how it will work if there is more than one value, that is, and it is a multiple of the length of this vector, okay, or array. So this thing you should understand. Next, what will be the output of this? I did not informed about how this will work, but I want you guys to guess what will be the outcome of this. So here you are saving these values inside x, and then you are calculating mode of x, and as I mentioned, mode, this is not a mode of measures of central tendency.
So character.
Yes, it will be a character, but see, let me tell you how it will work. See, when you are trying to put different values in a variable, it will not give an error, okay, but if, let's say, you are trying to put multiple values, okay, and if any of them is a string, it will save all these values as a string. For example, if I run this same command in R Studio or R, and if I again print my values of x, so you see, although I provided my values 2, 4 and 8 as numeric values, I did not put under any quotes, but since there was one value of that entire set which was string or character, it saved all these values under x as strings for compatibility, okay, unless you remove in quotes from here or you add, and if you are not doing either of these things, it will save all the values as strings or characters, okay, and since this x is saving all the values as characters, definitely mode of this entire x will be character, okay. Last, what is the output of this expression? So
option A.
let me check. I don't want to do this manually at this point. Yes, okay. So I hope everything is clear till here. If you guys have any doubt, you can ask. I can tell you one more thing. So till now we were dealing with vectors, okay. So here every time whether we saved strings or numbers, we were combining them using C, right? So here what we are doing is that we are just saving one sequence of numbers or strings in a variable. So that is an vector, okay. Now matrix, if you guys know, so in matrix we have rows and columns, okay, but in these matrices we have all values as numerical values, okay. So when you will be dealing with in R with huge data sets or other things, you will start encountering these things depending on what calculations you want to do, what type of data you have, so all those things will vary. So it can have, so vector will simply have a sequence of values. Okay, matrix will have rows and columns, but all numbers. There can be any number of rows, any number of columns. Okay, so that is the matrix. Array is a 3D structure. These two are primarily numerical values. Okay, these type of data sets, I work with neuroimaging and all. So there we see these 3D matrices or even 4D matrices. Okay, so these are also quite common. Okay, now data frame is slightly is different from matrix, that also has rows and columns. So what I showed you here as empty cars, this is not a matrix, instead this is a data frame. Okay, currently these are raw names, but instead of these being raw names, these can be one column as well. Okay, so there you can, instead of these row names, you can add them as a separate columns called cars. Okay, for which all of these informations are there. So in that case, what will happen is that you will have one column as strings or characters, second column you may have numbers, third you may have characters, and again numbers and so on. So tables are able to accommodate different types of information in different columns. Okay, so that's what data frames or tables do. Okay, so here different columns can vary, or data type can vary in different columns of table. Okay, however, that is not the case with matrix and arrays. List is another type of data structure where you can save all type of these things. For example, in first value you can save as an entire vector, second value you can have a 3D matrix, third value you can have a data frame, and so on. So list can accommodate everything. For example, let's say when you go to electronics shop, okay, you see mobile phone, you see laptops, you see other type of gadgets. Okay, so think of this as a matrix where when you go to a particular shop, you find that type of items. Okay, electronic items. Okay, now when let's say when you go to a supermarket, you can get electronics also, you can get fruits also, you can get electronics also, and many more things. Okay, and in list you can combine many more things. Okay, for example, books, fruits, and whatever thing. So this list thing is able to accommodate everything. Okay, and when you'll be doing calculations later on, okay, as of now we did not dealt with we did not saw till now what lists are actually. Okay, but as soon as you enter any t-test or simple where you compare difference between two variables, or when you do correlation, you do regression, and so on. Okay, you will see that whenever you do any t-test, okay, for example, okay, I will not do as of now. So you will see the output. Okay, there you will see the t value, you will see p value, and df, and so on. That's what you will see in a console. But what that particular function will be doing is that it will be saving multiple values, some characters, some p values which are numerical, some t values which are numerical, some variable names which are characters. So it will be saving all such informations in a list. Okay, and what it will be printing here is just some part of that list. Okay, so whenever you do any type of tests, okay, or higher order computations, all such functions store information in terms of lists. Okay, so, and usually people will not tell you those things. Okay, and what you see as an output is just part of that list. Okay, when you so you can go into these values or data there you will find that list, and when you will click on those drop down options, you will get more option. Again you will get many drop down more drop down options. Again when you click, you will get more option, and so on. So that's how lists work. It can have multiple information inside some other things, and so on. So this is a bit complex to understand without actually seeing it. Once we'll be doing any t-tests or any other tests, I will show you those things, how these things actually look. Okay, data frames I already showed you how it looks, but we'll see lists also, how these tests accommodate different information inside list, and how you can fetch any variable which is not printed in our console. Okay, because sometimes you are interested in those informations to put in your papers as per general requirements, but you need it. So in that case, you need to go into those lists and fetch the particular information. Okay, so that's it as of now. Any query that you guys have, this is a time to ask, else I will end the session and we can meet again in the next week regarding week 3. Yes, any question as of now? You can unmute, you can ask, you can type. No questions? Should I end the session? Okay, also I would like to tell you guys that all these sessions that we are doing are also available, will also be available on YouTube, and the links will be shared with you, and or you can simply fetch from your course our course page, and you will be get the recordings and this PPT, as well as these are scripts that I'm using during the lectures. I will save it and post it in a Google Drive folder, which from which you guys can access it, both PPT and any R content. So all those things will be available to you guys, and if you have any other question, you can post it in Google Classroom. Me or someone else will address that question as well. Okay, I will end the session now. Thank you everyone for attending. We'll meet next Saturday. Okay.